Welcome to the MasterMIND Club, your ultimate gateway into the world of Bitcoin mining. Whether you're just starting out or looking to scale your operations, our vibrant community of like-minded enthusiasts is here to support you every step of the way. Join us for weekly sessions led by industry pros, where you'll exchange ideas, brainstorm strategies, and stay motivated on your mining journey. From heat management to site optimization, our monthly deep dives cover the technical know-how you need to succeed. And with access to our entire back catalog, you'll never miss a beat. But that's not all. Our members enjoy exclusive one-on-one sessions with veteran miners, plus direct access to special pre-sales and insider opportunities at Bitcoin Mining World. Ready to take your mining to the next level? Join the MasterMIND Club today and secure your spot in the future of Bitcoin mining. Visit bitcoinminingworld.com or scan the QR code now. And now back to the show.
Yo, what is up, guys? Good morning. Happy Friday. Welcome to the first Mastermind of 2025. Well, first Mastermind Deep Dive. This one's going to be a good one. I put this together especially for the HeatPunks, but it's also for anybody who's just interested in Bitcoin mining. So we're glad to have you here. We're happy to have you as part of our Mastermind Club. Make sure to, if you guys are not part of our club, join the Mastermind Club by scanning this QR code. You guys can gain access to our weekly community sessions, our back catalog of videos, and we're putting on a lot of things for 2025. We're really excited to get this going. Before we get into our Mastermind Deep Dive today with Ryan from CryoByte, I have something I want to tell you guys about. So we are doing a Build a Mine boot camp in Fort Lauderdale the day before Mining Disrupt. So this will be Tuesday, March 25th from 8 a.m. to 6 p.m. You guys join this boot camp. You're going to learn more about building and optimizing a commercial scale immersion cooled or hydro cooled mining farm. At this course, attendees will learn about the Bitcoin mining business mindset, site selection, power purchase, and power distribution. We will have fog hashing there to demo one of their immersion and hydro tanks, and we will discuss containerized mining infrastructure. ASIC Master will show you guys how to troubleshoot your ASIC mining machines, read the kernel logs, and touch on the very basics of mining repair. So make sure you guys save your spot. The Build a Mine Bootcamp will fill up quickly. Scan that QR code on your screen or go to the link at the bottom there. Sign up. It's going to be a great time. So if you're going to be in Florida for the Mining Disrupt, make sure that you're there for the Build a Mine Bootcamp as well. All right, I'm going to bring up our creative director, John, because he's going to tell you guys about a networking event that we're going to be doing after this Mastermind Deep Dive. John, good morning.
Good morning, and thank you, Trevor, for having me on today. How are you doing? Are you warm, cold? What are you doing?
Man, I'm warm. I've got a little space heater in my studio right now, so it's nice and toasty. Unfortunately, it's not a Bitcoin mining space heater, not yet. But every time I get that thing in here, something happens. So I'm afraid that I don't want anything bad to happen to the studio because we are renting the space. It's got to be real careful.
So we're going to work on getting you a Bitcoin mining heater because I think that is only right. So Trevor, we are going to be traveling the world over the next couple of weeks. We're going to be in Colombia next week.
Yes,
we are. We're going to be in Naples, Florida next week at Bitcoin Day. We are going to be in Houston shortly after that. We're going to Denver to talk about heat reuse, which would give you that heater, right?
100%. Absolutely.
And then we're going to Fort Lauderdale. So we're going all over the place. We're going to put links in that chat so that if you guys are in Colombia, if you are in Florida, if you're in Houston, Texas, and you want to go see the Astros ballpark with me on Saturday morning and see a bunch of Bitcoin stuff, we can do all those things. But today we're going to be in a Zoom call where we can learn about what you're doing in your Bitcoin mining journey. If you're building a mine, if you are going to be optimizing your mine, and it's a great way that we can all interact. So we're going to give you some inside scoops on tickets to get into all of these things that I just mentioned, because we do have free tickets. And if you're in the neighborhood, we'll make sure that you get them. And we also got a raging after party that Scott is putting on, and it's going to be dope. Yeah, that's the only word that you can use for it. It's going to be off the hook, where people are going to make bad decisions a long way from home without the scrutiny of others judging them for what they do. So it's going to be a lot of fun. I look forward to seeing all of you at the MasterMIND networking event after this call, and in all of these wonderful warm places where it's not snowing and I don't have to wear this parka.
Yeah, definitely. So guys, scan that QR code at the bottom of your screen, join the networking event. It's also going to be shared in the comment section of the deep dive today. So you'll have plenty of opportunities to go to that link and get ready for that deep dive or the networking event. It's going to be a great time. Well, with that, guys, one more thing. Nope. I'm going to save that to the end. John, thank you so much. All right, we're going to bring up Ryan. Ryan is from CryoByte Labs. Ryan, how are you doing today, brother?
Doing great. Thank you, Trevor. Good morning and happy Friday to you.
Happy Friday to you too. So can you tell the audience a little bit about what you're going to be talking about today?
Yeah, definitely. So I'm excited to present on a subject that I'm very passionate about, one that I've been researching and really building over the course of the past 3 years, and it's about heat reuse. It's how we can capture heat from a miner and use it to have an economic advantage and leg up in the mining industry.
Yeah, it's something that I'm super passionate about. Anybody who's watched my podcast or listened to me talk a little bit knows that heat reuse is something that gets me fired up every day. I actually have a Bitcoin mining heater in my house that I use every day to warm myself up, get myself up to 72 degrees. My wife loves it. It's wife approved. So heat reuse, in my opinion, is what's going to change the Bitcoin mining industry for good. And we're already seeing things happen. You've got the BitX. I know it's not heat reuse necessarily, but it is open source. You've got Canaan coming out with baseboard heaters. You've got the DIYers and the HeatPunks doing a HeatPunk summit in Denver, which you're going to be at as well. So, it's a great opportunity to learn and grow when you get into the HeatPunk space. So I'm super excited about this presentation today, Ryan. I'm going to actually just let you take it away.
Sounds good. Thank you, Trevor.
Yeah, man.
So again, today I'm going to be talking all about heat reuse and how you can use it to stay competitive in a very competitive market. Right now, small miners are having trouble competing with large industrial miners, but utilizing that heat instead of a waste product can actually give you a leg up. So the title of my presentation today is From BTC to BTU, How Small Miners Can Stay Competitive by Utilizing Waste Heat. And I'll start off with a question you guys can answer in the chat if you'd like. Does anybody know what BTU stands for in that title? Feel free to throw any guess out there that you want. What does BTU stand for? Let's see if we have any guesses coming in. If not, I can just give you the answer. There it is, Andy with British Thermal Unit, and that is exactly correct. So BTU stands for British Thermal Unit, and it is, big time ugly, it is a way that you can measure heat. And it's important because regardless of whether you like it or not, your Bitcoin miner is going to produce both of these products. It's going to produce Bitcoin, of course, through hashing. And through that process, it's going to create heat. Now, for the most part, that waste heat is dumped into the environment because people only are after the Bitcoin. But we're going to talk about ways that you can actually leverage that heat to give you a leg up. So before we jump all the way in, I'm going to give you a quick introduction to me. Again, my name is Ryan Ramminager. I'm the founder and CEO of CryoByte Labs, and we focus on providing thermal solutions to proof-of-work miners. So whether you're looking to keep your miner cool or whether you want to capture that heat and repurpose it for another application, we are making the products and services that allow you to do so. I've been mining since 2012, which is crazy to say. So coming up on 13 years now. And I have a background in finance and economics. So a lot about how I view Bitcoin mining has an economic perspective on it. Now, as a quick disclaimer, this presentation obviously is just for educational purposes only. I'm going to be throwing out a lot of ballpark figures, a lot of round numbers, so it's not financial advice. But I really want you just to take some of this information and hopefully change the way that you look at mining so you can be more competitive and more efficient in your operation. And as always with Bitcoin, do not trust me, verify, do your own research, run your own numbers. There's a lot of information out there, and I encourage you to dig in and learn it yourself. So without any further ado, let's get started. So I want to set the stage by really figuring out where we are as an industry today. And it's important to review the history of how we got here. So this is a quick little history of Bitcoin mining infrastructure. Of course, when Satoshi mined the Genesis block, he did so on a CPU. That was the only way to mine back in 2009. So that was what you mined Bitcoin with. Now, a few smart people figured out that GPUs were actually much more efficient at mining. So they switched to GPUs, and this is when we start to see mining farms come alive. So I actually got in at the tail end of 2012, and I remember some of these GPU builds pretty vividly. And they were pretty crazy. You know, they were in people's basements, they were in their garages and their spare rooms in their house, and they were all meant just to mine Bitcoin. Now, as a business started to pick up, people found that FPGAs, field programmable gate arrays, were actually more efficient than even GPUs at mining Bitcoin. So the industry began to shift over to FPGAs, but those were quickly outshined by our beloved ASICs, the application-specific integrated circuits. And we've had, obviously, a tremendous run with the ASICs, and I think we will for a long time. So ASIC mining brought about a new era in Bitcoin mining called the industrial era. Here's a quick little graphic. You can't really make out the numbers that well, but that doesn't matter too much. This is from Luxor, of course, and on the left-hand side, highlighted in blue, is the pre-industrial era. This was 2015 and before. This is when you could really take a miner, any ASIC, a GPU, CPU, you could plug it in, and you could mine efficiently. It really didn't matter what your power cost was, because the revenue that you generated per kilowatt hour was so high that you were able to offset your costs very easily. But as the heat and competition started to turn up in mining, everybody was in an arms race to gather as many ASICs as they could. They started looking for cheaper and cheaper power in order to get a better profit. And you can see what that did to the revenue per kilowatt hour. It flatlined. And we see that today in the industry. It's a very competitive industry. You can't just take a miner anymore, plug it in, and print money. You have to find a lot of cheap power. You have to have a lot of advanced equipment. So it's very competitive, and my belief is it's going to continue to get even more competitive. A clear strategy emerged with this industrial era, and I like to describe it as an energy arbitrage. It's not technically an arbitrage, but it's easy to follow. An arbitrage is when you take something of low value over here and you instantly sell it for a higher value over here, and your profit is that margin in between. And this is the strategy that most Bitcoin miners use. You access cheap power, you scale, and you put hash rate behind that power. And the third step, everybody's favorite, you profit from it. And it's that profit in between your cheap power and the Bitcoin that you're producing. That's sort of your energy arbitrage. Now, there's a lot of evidence of this energy arbitrage across the industry. So in order to drive better profit margins and in order to stay in business, you really need cheap power. So we see that all over the place. We see these large industrial miners accessing low cost and large power purchase agreements, so locking in cheap power for a long time. You see miners creatively going after stranded energy, so energy that was not monetized before, like flare gas and different biomass solutions. That's geographically isolated. You now can load up a bunch of miners in a container, ship them out to a flare gas site, and as long as you have an internet connection, you can harness that very cheap power to mine efficiently. And then there's also excess energy, so hydro, solar, wind, all these renewables. They're constantly creating energy even if there's not demand for it. And Bitcoin miners are acting as a buyer of last resort, and they're able to harness that excess energy and mine profitably. And when you look at this from the side of a small scale miner, it kind of looks like it's the end of small scale mining, because how are you supposed to compete with an industrial scale miner that has access to very cheap power? They have access to massive amounts of that power. They can access capital. A lot of these industrial scale miners are now publicly traded companies. They can raise hundreds of millions of dollars. They can access in debt much easier than small scale miners can. So they have access to that capital to scale their operations. They benefit from economies of scale. You can think of it as the Costco of Bitcoin mining. When you buy a ton of miners in bulk, you typically get a discount. You also run facilities that benefit from economies of scale, having everything in one centralized location. They have the top talent in the industry, so they're able to use their money to attract top talent. And these people mine Bitcoin 24/7, 365. So they're very knowledgeable and experts in what they do. A lot of these industrial miners have strategic partners. So they'll partner with an ASIC manufacturer, and they'll have input on how the ASIC is made, and it will be customized for their mining operations. They also have the ability to run at a loss. When a bear market hits, they oftentimes have Bitcoin reserves. They have access to that capital. They can keep the lights on a lot longer than a small scale miner can. So as a miner, a small scale miner, how are you supposed to compete with these large miners? Well, in my opinion, I don't think that's an attractive strategy. I don't think that you're going to win trying to go against these miners who have all of those advantages over you. So what I would say, instead of focusing just on the energy arbitrage game, instead, you can actually utilize both of those products that your miner is creating. You can utilize both the BTC and the BTU, the heat. And this practice is often referred to as heat reuse. So what is the definition of heat reuse? It's the act of repurposing waste heat from mining equipment for practical applications. Pretty straightforward. But in practice, what that means is you are taking heat from the miner, and instead of rejecting it into the environment, you are simply replacing what you would normally pay for to heat. So for example, if you were heating a house, you have a cost every single month to heat that house. And if you can capture the heat from your miners to heat that same house, you therefore don't have to pay to heat that house. So it actually changes the economics behind mining. So it's very important to understand how your Bitcoin miner is producing this heat. Oh, let me go back. So your Bitcoin miner transforms roughly 95 to 100% of the energy that they're consuming to heat. And they work as what are known as resistive heaters. So it's actually the electrons flowing through the circuits in your miner. It bumps into atoms and it creates friction on the atomic level that then creates heat. So a miner that is consuming roughly 3 kilowatts of energy is going to produce 3 kilowatts of heat. It works very similar to how a space heater works, or like a blow dryer or a dryer in your home for your clothes. Those are all examples of resistive heaters. But that heat is actually a product. It's not a problem. Now, if you're an energy arbitrage miner, one of these large industrial miners, the heat is a problem. It actually can harmfully affect your ASICs, different electronics in your mining operation. It can affect your efficiencies. So these industrial size miners, they want to just dispose of the heat outside. And that's what we've done as an industry for a long time. You're only after the Bitcoin. The heat is a byproduct, a waste product, and you want to get rid of it. But as Tyler Stevens says, he's a very popular HeatPunk. If you haven't heard of him, I would definitely recommend. He has a good quote that I like where he says, heat is a product. It's not a problem. And it's very true. We pay for heat and we need heat every day in our lives. Everything around us, the world that we live in today, requires heating. And we pay for that right now. Historically speaking, I thought this would be fun. In the chat, can you name some products that were originally waste products, but actually turned out to be very valuable? There's one that a lot of people know, and there's a few more that I researched that were pretty interesting, but let's see what you guys can come up with. Do you have any idea of waste products that ended up actually being very valuable anytime in history? I'll give it a few minutes to let some answers roll in. See if anybody gets the obvious one. Landfill methane, yes, that is correct. That is now being harnessed as energy. That is a great one. Pretty cool to mine Bitcoin with that as well. And I'll just kind of name some other ones. Tires, yep, tires are being recycled. They used to be discarded and buried, and now we can transform that into energy and other products. The biggest one that people tend to think of is gasoline. So historically, gasoline was discarded as a waste product. When you were refining kerosene, the gasoline was too volatile. It didn't have a purpose, so you ended up tossing it out. And if you look at the economy and the world we live in today, I don't think we would be able to function without gasoline. It's a huge industry, a mega industry that was once a waste product. Another couple examples that I researched, one was molasses. Molasses is a byproduct of sugar refining. It was always tossed out until some genius said, hey, we can make rum with that. So rum is made with molasses. You can make ethanol from molasses for other various purposes. It's in food, it's in livestock feed, so it's actually a huge industry of itself. In addition, whey protein was another one that I stumbled upon. It's a byproduct of cheese manufacturing. And then another smart guy said, hey, that's actually an excellent source of protein. Why are we throwing that away? Let's turn that into whey protein shakes and now look at the industry around that. So historically, we've always seen a bunch of waste products being tossed out that end up having a lot of value. So to get to this next slide, if you wanted to quantify that value and you look at that, over 50% of all the energy produced in the world is produced just to heat things. That to me was a staggering number. So all of the energy in the world, think about planes flying overhead, cars driving, lights in a city, 50% of all the energy used or created is used to heat things. That's huge. Now, if you were like me, you might think, okay, well, it's probably for giant industrial reasons to create steam or to create steel, things like that. But actually 20% of the global energy production is used to produce very low-grade heat. This is heat that is less than 80 degrees Celsius. And that number is important because that 80 degrees is now achievable by Bitcoin mining. So another way to view this is 20% of all the energy used in the world produces heat that could theoretically be produced by Bitcoin Bitcoin miners as a waste product. There's a lot of opportunity there to reuse heat. Here are some of the use cases for that very low grade heat. So residential space heating is the biggest one. 7.5% of all the world's energy goes in just to keeping houses warm, just to keep you warm at night, setting your thermostat at 70 degrees in the wintertime or whatnot, keeping you warm. Commercial space heating, the same thing. Heating your water, being able to take a warm shower uses 3.75% of all the world's energy. And you go down the line with food and beverage manufacturing, pulp and paper industry, greenhouses, which people are using Bitcoin miners to heat, uses 0.75% of the world's global energy. Crop drying and agricultural use. My uncle is actually a farmer, and every year he has to dry out his grain. When he puts the beans or corn in the silo, he has to remove the moisture from them in order to keep them from spoiling and going bad. And he has to get within a certain percentage or else he gets docked when he sells the grain. But he knows going in every single year, this is going to be a business expense. He's expecting to pay for that heat, and he needs a ton of that heat in order to dry out his crops. So if you look at all these use cases, there's a lot of different areas where Bitcoin heat could be repurposed in order to save energy that we're already spending. If you compare that to the global Bitcoin network, assuming an 800 exahash network, we're a little bit above that, an efficiency of 25 joules per terahash, and the very low grade heat constant power consumption of 2.5 terawatts, which is just a flattened curve of average production. If we replace just 1% of very low grade heat, we could more than double the Bitcoin network. And that is crazy. So replacing just 1% of that heat would more than double the Bitcoin network based on the power consumption that we use to create that heat. Now, as people are saying, I think somebody just commented actually, it depends on the original energy source and conversion efficiency. That's correct. So not so fast. All heat is not created equal. And that's why we wanted to point out at the very beginning of how your Bitcoin miner produces heat. It's a resistive heater. And it actually is one of the least efficient ways to produce that heat. That's why we use things like natural gas and heat pumps, biomass, things like that. We don't have space heaters all around our house because we would be paying 3 or 4 times more to heat our home than using natural gas or a heat pump. So it's important to know that. Here's a general breakdown, and this is very ballpark, very relative, or in general. So don't take this as gospel. This is more just as a guideline. If you were to create heat using different heating methods, this is the relative percentage cost compared to electric resistive heating. So if I were to use heating oil like some old homes do, I could expect to pay 70 to 90% of what I would be paying to create electric resistive heating. Propane, 60 to 80, you can go down that list. If you look at the heat pumps and natural gas, you can see here that running a heat pump or using natural gas to provide heat is usually about 3 to 4 times less expensive than it would be to create that heat using electric resistive heating, aka Bitcoin mining. So you're able to produce heat much more efficiently using different methods. But there's still massive opportunity here. And this is the concept. There are 2 reasons. So the first is that with Bitcoin mining, you are producing 2 products with 1 energy input. So all those other methods that I just showed you, none of those produce anything of value other than the heat itself. They're not paying you to produce that heat. But with Bitcoin mining, you're producing Bitcoin and you're producing that heat. So if the sum economically of your Bitcoin and your heat production are higher than the inefficiency of producing that heat, you're actually better off economically by producing heat via Bitcoin mining or electric resistive heating. The second concept here is that heat consumers expect to have a loss. Again, when I'm heating my home, I know I'm going to have an energy bill every month, and I know I'm going to have to pay that, and I'm perfectly fine with that to keep my home warm. My uncle, the farmer, he knows that he's going to have to dry his grain out. He actually uses propane to do that because of his system he has set up there. And he knows that that's going to be a big expense every year to dry out that grain. Now, this is nice because that means as a Bitcoin miner, in order to produce that heat, I actually don't need to mine for profit. I can actually mine at a loss. And again, as long as my total economic output from that heat and the Bitcoin itself are higher than what I would have paid for that heat, then I'm actually better off economically. So even though Bitcoin miners produce heat less efficiently than other methods, there are a lot of examples where the economic benefit is actually better because you get Bitcoin on the back end. So if we were to break this down, this is again is general just for you to get an idea of what an what your power rate could look like. If you were to replace different heating methods with Bitcoin mining, you could actually lower your net effective power rate with that heat reuse. So if I'm replacing existing electric resistive heating, I'm actually mining at a power cost of 0. I'm mining for free. I was going to produce that heat at the same efficiency for the same cost. So now all the Bitcoin I'm mining is actually just free on the back end. It's a power cost of 0. An excellent example of this, as I was actually making this presentation, I was thinking of it. In college, I rented a home that had electric resistive heating. The landlord was not going to spend $15,000 to upgrade the system to a nice, efficient central air. He didn't really care because people would rent his house for a year and then move on. Now, me as a renter, I'm not going to put money into his house either, so I just used the electric resistive heating. It was expensive, but at the end of the day, if I would have replaced that heat generation with Bitcoin mining, I would have produced the same amount of heat at the same cost, but I would have got Bitcoin basically for free. So, quick question. Jordan has a question. How can you say they produce heat less efficiently when earlier you said they convert 100% of electricity to heat? That's a good question. With electric resistive heating, you're taking the electricity and you're converting all of that electricity into heat. But there's more efficient ways thermodynamically to create heat. So a heat pump doesn't create heat via electricity. It actually moves heat from cold and hot regions. So that's a good question. It's kind of hard to think about, but the other ways to produce heat, they don't use electricity to do that. They might be plugged in. Your furnace is plugged in for blower motors and things like that, but it's actually heating that or igniting that propane, and the propane is what is creating the heat more efficiently than the electric. So hopefully that helps to answer your question. But if we continue down this list here, if you were to replace, say, heating oil, older homes, some of the older homes still use heating oil. If you were to replace that cost, you would basically net 80% of the value of that heat, and you would effectively be mining at a 2 cent per kilowatt hour rate if you started at a 10 cent per kilowatt hour rate. And you can go down the line here. Propane gas is 3 cents per kilowatt hour. Biomass is 4 cents per kilowatt hour. And what you notice there is those are rates that industrial miners are even trying to get. 2 to 3 cents is maybe average for them, but electric resistive heating, if you're replacing that, you're mining at a zero cost. Your Bitcoin is basically free. That is an excellent way that small miners can stay competitive when these industrial miners are locking in electric rates at those prices. So even when you get down to natural gas and air source heat pumps and things like that, you're getting into the 6 and 7 cent range. That's still not a bad rate to mine at. That's similar to some hosting opportunities that you might see. So if you're on that borderline where maybe 10 cents wouldn't make sense for a mining operation, but if you can reuse some of that waste heat, it actually lowers your overall cost, and then it might push you into that profitability point. So this is just a general idea of how you can actually harness waste heat to help reduce your overall cost in mining. But wait, there's more. So it's not just the cost of your electricity or the cost of you running that miner that would be affected. There's also symbiotic relationships between heat reuse and miner cooling. So oftentimes, if your heat application is actually consuming that heat, you can either, in a closed loop cycle, return cold water, return colder air, and it will actually help improve the cooling of your system. So you can reduce your cooling costs to your miner by 5, 10, 15% just by using a heat application that consumes that heat. It's also environmentally friendly. Like we keep talking about, you're completing 2 tasks with 1 energy input. And if your economic benefit of those 2 tasks outweighs what it would cost you to complete 1 task individually, then you're actually consuming less overall energy. So instead of creating heat by itself and then mining Bitcoin by itself, if I do them together, I'm consuming less overall energy, which is better for the environment. It helps decentralize the hash rate as well. So instead of having these giant hashing centralized entities, there's heat reuse needs all over the world geographically and in small little pockets. Like we saw, residential heating consumes a ton of global energy, and heating a house all over the world could help decentralize the hash rate and create a very healthy mix of industrial miners as well as smaller decentralized mining operations. It produces a much more resilient and less price sensitive network as well. So the example I gave, whereas if you're replacing electric resistive heating, you're mining basically for free. I don't care if Bitcoin's at 100,000, 50,000, or $10. That Bitcoin is a value add on the back end. I'm still paying the same amount that I would have paid to heat my home or my facility using electric resistive heating. So that Bitcoin price doesn't matter at all. And this is important because if we have drops in Bitcoin, if we have bear markets, we won't see as much hash power go offline. That can help build up a more robust and resilient Bitcoin network. So there's actually a lot of benefits, both economically and for the benefit of the network, of the Bitcoin network, to reuse heat. In fact, Satoshi said that he thought that Bitcoin mining would actually start to locate in areas where it was colder because of the ability for heat reuse. Now, I don't know if this is going to play. We'll give it a shot, but I'm throwing a lot out at you about heat reuse. But this is Fred Thiel. He is the CEO of Marathon Digital Holdings. They are one of the largest miners, not just in the United States, but in the entire world. Let's see if this plays. It does not. Basically, he gave a presentation 6 months ago, and he talked about the initiatives that Marathon is doing for heat reuse. They are big fans of heat reuse, and they see this as the future of the industry because they're able to mine at a much more effective rate. They, instead of tossing that heat into the environment, can provide value elsewhere. They actually have a pilot project going on right now in Finland where they're capturing their heat from either hydro or immersion cooled miners. They're pumping that heat into a city facility that's already been set up in Finland that heats homes using that hot water. So they're able to supply homes with heat. They're able to get economic benefit from that. And they're still mining Bitcoin just like they regularly would. So there's a ton of potential. And even these big industrial miners are starting to see that. But right now, small miners can really take advantage of that and start future-proofing your business and get ahead of those industrial miners. So to summarize, I know I've thrown a ton at you, and we'll have a Q&A after this that I can answer questions. I'll also be at that happy hour, and I'd be more than happy to answer any questions you have there. But to summarize, heat reuse presents a very powerful opportunity for small miners to stay competitive. It makes both financial and environmental sense. You can really lower your overall cost of mining and make mining on a smaller scale more profitable and efficient. It's also very healthy for the Bitcoin network. We want a healthy mix of industrial miners, small miners, medium miners, everything in between. So if we can decentralize hash rate, and if we can reheat or use that waste heat to heat things, it creates a healthier network. Now I'm going to switch gears real quick, and I'm going to talk about what we are doing at CryoByte that can help miners achieve your goals, whether it's to better cool your machine and run a more efficient operation, or whether you want to capture that heat for reuse purposes. Again, we are designing products and services that can help miners achieve that. The first thing that you're going to want to know, though, is just how important cooling is to your overall mining operation. So this is data that we did on a little study a while ago that was aimed to see how the ASIC temperature would affect your efficiency. The test that we did here, all we did was lower the fan speed down by small increments. And that was just so we could increase the ASIC temperature. So everything else stayed constant. The ambient temperature fluctuated a little bit, but not enough to throw off the general consensus of the data. So if you see here, as we slowed that air or that fan speed down, you would think that we would conserve energy because our fans aren't using as much of that energy. But in fact, our ASIC temperatures rose. And when the ASIC temperatures get warmer, they actually consume more power. So as we were a few degrees above where we started, we were consuming about 60 watts more power. So not a huge difference, but definitely a decrease to our efficiency. But it starts to scale quickly. As you can see here, once we start reaching 10 and 20 degrees, we start seeing efficiency drops of over 10%. So we're using 10% more energy to hash at the same hash settings simply because our ASICs are running at a hotter temperature. So cooling is extremely important to your overall efficiency. It's a good way to eke out 5 or 10% increases in efficiency just by keeping your miner running cool. And it's not just the cost savings that the temperature affects. So heat can cause thermal stress within your miner, and it can affect the miner lifespan. If you're running a miner very hot and heavy, not only are you mining inefficiently, but you're going to cause that miner most likely to fail faster. It's going to have a shorter lifespan than a miner that is well cooled. So cooling is extremely important, not just for heat reuse applications, but also for mining in general. Even if you're running in one of those energy arbitrage industrial size facilities, you're going to want to pay close attention to how cool you can keep your machines. We were not the first ones or the only ones to discover this. In fact, this is from Brains, a popular firmware producer. They ran basically the same exact scenario and they had the same exact results. You can see here that just based on temperature, you can actually have a kilowatt more of energy use when your ASICs are running hotter. Now that's a wide temperature range, so that's probably not going to be that drastic in real life. But if you're saving a few hundred watts of energy, you're mining 10% more efficiently, you're getting more hash rate, you're using less energy, you have more overhead in your mining facility to put more machines in, you're really maximizing all that energy to its full potential. So cooling is extremely essential. Now the question we get asked a lot is, okay, if cooling is so essential, should I be using air cooling, immersion cooling, or hydro cooling? And the answer truly is it depends. There are so many factors that affect this question. So there's no right or wrong method. A lot of miners have cooling methods that they prefer. So in general, though, what we found is that for smaller miners, if you were to use hydro or direct to chip, you actually tend to get the best cooling performance, which gives you the best overall efficiencies, especially when you account for cost. So there are some small miners that are getting into immersion mining, and there are a lot of benefits to immersion mining. But if you look at the overall efficiencies and the overall cost, for a lot of small miners, hydro is actually a better option. Now, there are barriers to get into hydro, especially as a small miner. So hydro cooling tends to be focused on the large industrial miners. Hydro does such a good job at cooling your chips that you can actually densely pack a miner and consume a ton of energy in a very high hash rate by cooling with water. So you're creating these very power dense machines that consume a ton of power, and they need to run on 3-phase power. And then you have to have complex cooling infrastructure. You have to have giant dry coolers if you're moving the heat outdoors. You have to have piping and all this stuff run. So it doesn't make sense for a heat reuse application. You know, I'm not going to put a data center in a greenhouse simply to reuse the heat. But if I want to mine efficiently, and if I want the other benefits of hydro cooling, you know, it's really not attainable as a small miner. So at CryoByte, we saw this as an opportunity. What we really want to do is bring hydro cooling to small miners into heat reuse applications. We want to give you all the benefits that the big industrial size miners get with hydro cooling. And we want to pare that down and make it affordable and attainable to small miners. So we actually came up with our own direct-to-chip liquid cooling solution. This is made to focus on optimizing your energy efficiency, again, keeping your miner running cool so it consumes less power and has better efficiency, but also gives you the ability to then capture that heat in liquid for heat reuse. Now, what were pictured here are our CryoBlocks. So the CryoBlock is actually the cold plate of the system. These are a patent pending design that allow you to cool your device much more efficiently. And those are part of an overall upgrade kit. So you can actually purchase an upgrade kit to upgrade an air-cooled miner. And those CryoBlocks simply replace the heat sinks on your air-cooled miner. So you unscrew the heat sinks, you put the CryoBlocks on, and then you're able to circulate water or coolant through those blocks. You provide better cooling, you capture that heat from the ASIC chips via liquid, and it gives you the increases in efficiency, gives you increases in performance. You can actually overclock your miners by a crazy amount, where the PSU ends up being your top limit and your bottleneck and not so much the temperature. And it also takes the thermal stress off of that miner, so you can actually increase the lifespan of that miner. You're also not pushing a ton of air through that miner anymore, so you don't have those loud cooling fans, so you reduce your noise, you reduce the downtime, you don't have all that dust accumulating internally there, so you reduce the maintenance cost as well. So there's a lot of benefits to upgrading an air-cooled miner to be a powerful hydro-cooled miner. Now, it's also great for heat reuse. Like I've been saying, you can actually capture that heat from the ASIC chips in liquid. Liquid is much more efficient to move and to pump places. So if I wanted to move the heat outdoors, it's a lot easier for me and more efficient for me to pump it as a liquid than to try to pump it as air. Air does not move nearly as efficiently. So I can actually expand my heat reuse by capturing in liquid too. I can then heat other liquid applications. So I could heat a swimming pool or a hot tub or a water heater. So you can use liquid to liquid plate heat exchangers that then allow you to expand your heat reuse applications. One of my favorite benefits of upgrading a miner is the ability to have a flexible form factor. When you think about an air-cooled miner, you are forcing the air through the hash boards of your miner, and you really don't have any other option when it comes to air cooling. You just have to push through as much air as you can through that same form factor in order to cool your machine. But when you actually capture that heat from inside your miner and you put it out, you extract that heat, you then have the flexibility to exhaust that heat over any form factor that you want. So you can pump it outside to a dry cooler. You could use a nice little compact desktop radiator unit that actually can exhaust that heat. And that's exactly what we did in an experiment. We actually had an air-cooled stock S19, and it was running right next to an upgraded with our upgraded CryoBlock kit. And we had a tiny little radiator next to it to exhaust that heat. And what we ended up seeing is that both miners were consuming the exact same amount of power. They were hashing at the exact same setting, so everything was identical, the same environment, all of that. Our upgraded miner that used the small radiator unit to cool it was 3 to 4 times quieter to the human ear than the stock air-cooled miner. And why this is such a big deal is noise is actually a big concern for a lot of smaller miners. If you want to mine at home, like Trevor likes to say, wife approved, your wife is not going to like a 75 decibel miner screaming away in the basement. But if you can extract that heat and you can eject it over a different form factor, and you can reduce the noise by 3 to 4 times, it sounds just like a space heater. In fact, when we were running these tests, they were right next to my office. When the stock air-cooled miner is on, obviously it's quite loud and annoying. But when it was our miner running with our upgraded kit, you couldn't even hear it when the door was closed. So you'd walk into my office, couldn't even hear the miner at all. So this can help expand those heat reuse cases, because you get into a dilemma of, as we saw before, when you slow your fans down on your miner, you start consuming a lot more energy. You're mining way less efficiently. You're leaving a lot of money on the table. But you don't want that noise, so you kind of have a dilemma. Do you want slower fans and less noise, or do you want better cooling with a very loud, annoying miner next to you? Well, with our heat upgrade units, with these kits that we provide, you can actually get the best of both worlds. You can provide that same cooling. You can run at the same efficiencies or better efficiencies, while also reducing the noise. So you get the best of both worlds. Now, the power comes from our upgraded water blocks, those CryoBlocks, as I called them before. So we packed a lot of technology into those. They just look like normal cooling blocks to most people, but internally, we've done a lot to improve heat dissipation. So we've been able to modify the flow of the coolant, and it flows in a much more efficient way to provide even cooling to all your chips. Now, this is a CFD, a computational fluid dynamic analysis that we performed, comparing our CryoBlock on the right to a standard water block on the left. And as you can see, we have much better cooling. We eliminate a ton of hot spots. We're able to give a much more even, consistent temperature profile to all your ASIC chips. In addition to optimized flow of coolant, we have internal microfin structures that allow you to dissipate heat much more efficiently. And what this means to you as a miner is you're going to get better cooling. You're going to have chips that run at lower temperatures. You're going to get higher efficiencies. You're going to get longer lifespan with your miner because you're providing it better cooling. Now, an example of this in the real world, so this is actually one of our units. We ran a test here. We were about 25 degrees Celsius on an ambient temperature, but our maximum chip temperature, the hottest temperature on the entire unit, was only running at 49.5 degrees. And that's insane. So you don't see that type of cooling on a standard air-cooled miner. You don't even see that on an immersion system or even a hydro system. But it's thanks to our cryo blocks that we're able to provide a lot of cooling. So if you're in a high heat environment, even here where I'm located in Ohio, the temperature gets really hot in the summertime. In fact, we had a warehouse that we ran tests on where it was 104 degrees Fahrenheit in the summertime, peak of summer in July. We had a miner running in there. We had no ventilation, so no air moving in or out of this warehouse. And that miner was running with chip temperatures that were in the 60s at the highest temperatures. So running very efficiently, even in an extremely hot environment. There's no thermal throttling, so you have higher uptimes. You're really reducing the thermal stress that your miner experiences. So there's a ton of opportunity for miners there in high heat environments. Like I mentioned before, you can also overclock these things. When you overclock, you start raising your temperature quite quickly. And as we saw from all those previous studies and tests, that really decreases your mining efficiency. So as long as you're keeping your miner cool, you can actually perform these overclocks. You can overclock at a higher rate, and you can do so much more efficiently than just a standard air-cooled miner. Another thing that we did, and it's hard to see here, but we ran a side-by-side to compare energy savings. We ran a stock S19 next to an upgraded S19 with our cryo blocks installed. And what we saw was a 14 degrees Celsius lower chip temperature. We consumed 410 watts less with the upgraded miner. So again, same exact environment, same conditions. Our upgraded miner with our hydro-cooled direct-to-chip solutions ran much better. Thank you, Chad. Chad just said he can confirm that he burned up two out of 3 boards on an S21 overclocking with air cooled. And that's exactly right. Your chips are experiencing a lot of thermal stress. Even sometimes when they say they're in the appropriate limit, it's honestly like a silent killer. Everything can look fine, but if you're pushing those chips farther, they're going to end up getting burned out quicker. So as long as you are providing adequate cooling, especially via a CryoBlock, you're able to overclock those efficiently and safely. So I know I'm just spitballing at you. I'm throwing a ton of information, but overall, if you want to run a more efficient mining operation, what I would beg you to do is look at your cooling, because cooling is a good way that you can eke out 5, 10, 15% increases in efficiency by increasing your miner's performance, the lifespan. You reduce the noise, the downtime. And if you are looking at heat reuse applications like we talked about during this presentation, capturing that heat in liquid form gives you the ability to expand those applications and make them a lot better. So I appreciate you guys listening to me ramble for a little bit. I'm going to actually hand it back to Trevor. Trevor, do you have any thoughts on heat reuse and about some builds that you have in mind?
Man, I have tons of thoughts. I have so many things running through my mind right now. One of the biggest things that I'm looking forward to building is a radiant heat floor system. I don't know if any of you are familiar with Cade Peterson from Softwarm LLC, but he has done several radiant heat systems going through concrete to create snow melt systems. Now, my thought is that taking a CryoBlock direct to chip upgrade unit and running that water through a heat exchanger through, or even just straight through the tubes themselves into a radiant floor system to heat my home. That is an idea that I've been thinking about for a while. But some other ideas that I've been thinking about is hot water heaters. Obviously the temperatures that these chips get to are not quite hot enough to boil water, not quite hot enough to get us to 136 degrees Fahrenheit. However, we can get to a temperature range of between 90 and 110, depending on what units you're using. And if you created a buffer tank to preheat water before it goes into your hot water tank, you can actually reduce the electrical load needed to heat your water from, ambient temperature up to 136 degrees. So these are just some ideas that I've been spitballing with, and some people have been working on, but it'd be interesting to see how the CryoBlock can increase those efficiencies.
Yeah, definitely. And again, it comes back to being able to produce that heat, but also keep your miner running efficiently. And that's really what we wanted to do with our CryoBlock. So it would give you the ability to do both of those. You can do a radiant or hydronic floor heating system simply by circulating that water. And again, that's one of those implications where there's a symbiotic relationship, because as you're running that heat through your floor, it's coming and heating your home. And then on the return loop, it's returning cold water back to your miner. So you don't actually need to have a dry cooler. You don't need a radiator. It's a closed loop system where you're consuming that heat on one end and you're producing it much more efficiently on the other end. So that's a great example, Trevor.
Yeah, definitely. Especially for, some of those cold winter days. It's January, so it's starting to get cold where I'm at. Not as cold as other people. Scott lives in a much colder place than I do. So, yeah, it's very curious to see where this space is going. I am curious, what are some of the, you spoke a lot about the implications and the reasons why someone would want to get into heat use, but what are some of the ideological reasons why someone would want to use heat reuse to mine Bitcoin?
Yeah, that's a good question. I think it goes back to supporting the network, right? We see a lot of centralization around mining. And although I love industrial mining, I think it's very healthy. It has brought a lot of expertise and money into the industry. It's really made it professional, which is great. But there are some risks involved. You don't want to get over centralized. We don't want to rely on a few companies harnessing all the mining power. So ideologically, in order to keep Bitcoin decentralized and to strengthen and create a healthy Bitcoin network, heat reuse is the perfect example, because miners are not going to find 2 and 3 cent per kilowatt hour rates. So you have to utilize the BTUs, the heat coming from your miner, in order to supplement and offset that lack of a cheap power cost. So I think it's great for the network overall. And that's really what I hope to achieve with a lot of this, is how can we make it so small miners still have a say in mining?
Yeah, completely agree on that. So guys, we're now going to do the Q&A session. So if you have any questions for Ryan, please throw them in the chat. I will make sure that those questions get thrown up on the screen and we can get those questions answered. The first question we have right now is from Mary. Mary is asking, so would there be a contract with the electrical supplier side or on the retail side? If on retail side, would there be pass-through charges from the supplier to the retailer? Curious about the mechanics of this sell back to the power company.
So not so much on the power company side. So you're still consuming the power just like you normally would. The thing that you're doing is you're capturing that heat and you're reusing the heat that you would then offset other power costs. So for example, if I have a miner running in my home that's producing heat, I then do not have to pay as much in my natural gas costs. So it lowers my cost there. So it's actually not an agreement I have to have with any utility. I still consume the power just like I normally would, but it helps offset additional costs. And that's really where the heat reuse is beneficial. So again, no need to have any special contracts or sell anything back. You're just consuming heat differently or power differently, and you're creating Bitcoin and heat with it instead of just heat.
So I have a question for you while we're waiting for some more questions to come in. So traditional direct-to-chip coolers for ASIC miners have historically not been very good at heating up or cooling down the boards as you showed, but they also don't do any heat cooling for the backside of your hash boards. What is CryoBlock doing to address this situation where the backside of the hash boards don't get cooled as much as the front side?
That's an excellent question, Trevor. So we use something that's called hybrid cooling. It uses both water and air to cool your miner. So when you upgrade your miner, you actually are going to leave the back fans on the unit. And those back fans can be controlled to pull air through the unit still. So like you said, with traditional hydro-cooled miners, they're simply running cold water through and you're cooling at the chip level. But there are other components on your hash board that create heat. You have your capacitors, you have resistors, and all these other small components that are creating heat. And if you don't keep those cool, those can end up breaking as well. And then your entire hash board is offline because you have a capacitor that went bad. By utilizing the hybrid cooling, so keeping those back fans intact, you're able to cool all the components on your board as well as your ASIC chips. So it kind of gives you a 2-for-1. And hybrid cooling is actually really interesting. There's a lot of like AI companies looking into it because it's a more efficient way to cool, because you're targeting hotspots. So with water cooling, you're targeting the dense heat from ASIC chips. That's where the majority of the heat is produced. But then you let that air cooling come through and cool off all the miscellaneous components to keep them running smooth as well. So good question.
Yeah. So Chad asks, here, I'm going to post this up. Chad asks, is there a way to daisy chain these coolers, or do they each need to have a separate fan radiator setup?
Great question. And there's a ton of flexibility with this. So you can actually just have a manifold that distributes water. And say you had 3 of these set up. Instead of having a separate radiator unit for each, you could have a manifold that equally distributes the water, and then a manifold that equally collects the water. And then you only need to have 1 radiator unit to cool all of them. Really, all you need to do is provide cool water up to about 40 or 50 degrees Celsius even we can use to cool these machines. So whether you use them as individual radiators or you daisy chain them all together using manifolds, you can cool a whole range of these. It works very similar to how hydro cooling works. If you've ever seen like a Bitmain hydro cooling, they have manifolds that just distribute water, but they only have 1 dry cooler that's running and cooling maybe 200 miners. So our systems work exactly the same way. It can be as little as 1 miner. You can daisy chain 10 of them together with a dry cooler. You can have 10 of them operating separately with smaller radiator units. You have a ton of flexibility. So hopefully that answers your question, Chad.
All right. Let's see. Rita just posted up here. You need to be careful with that as you get manifold flow, so cooling will be lopsided. Could you address that?
As long as your manifolds are producing flow at approximately the same rates, you're not going to have any issues. And that's the same thing. Like I said, this is how hydro miners run right now. They run through a manifold. That manifold distributes that flow somewhat evenly to the miners. And here's what I'll say as well. You don't need to have, there's a wide range of flow that you can provide for your cooling needs. So if I had one miner running at, say, 8 liters per minute of flow, and I had another miner running at 12 liters per minute flow, there's a big difference in flow rate between those two. And the one running at 12 liters per minute would be a little bit more efficient, but they would both be cooled adequately. So your manifold doesn't need to be perfect. There's no high-end engineering here. As long as you get appropriate or at least some flow to the miners, they're going to be cooled pretty well.
Awesome. Well, thank you so much, Ryan. We don't really have much time for any more questions. We've got this after party starting here in a second. But before we get that, Ryan, you have graciously offered to give away one of these CryoBlock upgrade kits to our audience here. And we're going to be doing this giveaway for about a month. And I'm going to show you guys the QR code for that giveaway. So if you scan the QR code on your screen right now, you will get a chance to win this CryoBlock upgrade kit. So you can play around, test it, see how well it works, and see the efficiencies for yourself. So one more time, scan the QR code on your screen right now for that opportunity to win that. Ryan, when can we expect to see these products hit the market?
So we actually just got our second version of our CryoBlocks in a mass quantity. So we should be here in the coming week, I would say, Trevor, be able to offer these to people to purchase. So this has been a lot of technology, going through all of the testing, the prototyping, making sure all the computational fluid dynamic analysis. We put a lot of time and energy into this. And just now we're coming out with the finalized product that people can buy. So I would say within the month, you'll be able to purchase these on the market, which I'm very excited about.
Yeah, I'm super excited about it too. This is something I'm a huge heat punk. I love heat reuse technologies and opportunities, and it's going to be a new wave of the future coming into being able to directly cool these chips and use air as well. So it's super exciting. I appreciate you so much for coming on today, Ryan. Thank you for everything that you're doing over at CryoBlock. Thank you for your presentation today, and thank you for being a part of Bitcoin mining world.
Thanks, man. I really appreciate it, Trevor, and thank you for having me on here. It's been a blast.
Awesome. All right, guys, well, check it out. One more time, the Mastermind Network event is starting now. They're over there in the Zoom call, making sure that you are getting your questions answered. And finally, I just want to say one more time, we are going to be doing a Build a Mine boot camp in Fort Lauderdale. Okay, come down the day before Mining Disrupt, join the Build a Mine boot camp. Fog hashing is going to be there. ASIC Master is going to be there. You're going to learn how these immersion tanks work, the hydro cooling works. You're also going to learn how to diagnose and fix your miners in some sort of aspect. It's not going to be a full in-depth how to fix, but you're going to learn how to read these kernel logs. It's going to be very helpful to you as a starting Bitcoin miner. So scan that QR code on the screen to sign up. Meet us in Fort Lauderdale for Mining Disrupt. Well, guys, we're going to see you over in the Zoom call. Thank you so much, Ryan, and have a good day.
Thank you for joining us in the Mastermind Club, your ultimate gateway into the world of Bitcoin mining. Whether you're just starting out or looking to scale your operations, our vibrant community of like-minded enthusiasts is here to support you every step of the way. Join us next week where you'll exchange ideas, brainstorm strategies, and stay motivated on your mining journey. Thank you for joining us, and tune in next week.